Hello everyone. So in this video, we are going to design Google Maps. Before we start, maybe why do we need to create another YouTube video when there are a couple of videos available on YouTube? So my personal experience, maybe the continuity was broken in those videos. That's why I created this this design talk and tried to record this video. So that we know what all things we are going to cover and the sequence order as well, so that at least continuity doesn't break for us. Yeah, that was my major goal. So now let's start. So whenever we see or maybe think of some Google Maps designing, right? One thing which we can think of, let's say, we might be running some pathfinding algorithm. Let's say it is just on the millions of the nodes and edges, right, on entire map, entire world map. So that's not the case. Maybe if Google Maps will do, right, run the pathfinding algorithm on in millions of nodes and edges on entire world, right, the system will definitely break. So we'll go through this and understand. So now let's see what all things we are going to cover as part of this video, so that we have the clear goal what all things we're going to cover. So first and first we'll try to understand the scope, what is the expectations from us, system boundaries. Then we'll gather the functional and non-functional requirement for us. Then we also do some calculations for map tile service loading and the real-time traffic load. So when I say the map tile, let me explain this. So let's say if this is a map of certain city, right? So if you have observed any of the maps, basically there are certain grids or tiles, that's how basically it's kind of loaded. And this is what a tile basically means. So let's say if I have a node here A, a B, and then there is path exists. So based on this coordinate system x comma y, I know which particular tile this node belong to. And the real-time traffic injection, why do we need, the real-time traffic injection? So that we know the ETA, if I have multiple path from going from A to B and similar distances, right? So I need to know which is the optimal path based on the traffic update as well. So that's why we need to know these loads time for sure for us. Then we'll move ahead for external API designing, where the minimum things we needed the search, first API for the tiles, search, routing, and the traffic injection. So these will be the four APIs which we'll try to cover. Then we'll see some high-level architecture diagram, which will consist of the client layer. In application layer, there will be multiple microservices and the data layer. Once we cover this high-level architecture, we'll try to dig down more deeper. We'll go through the core system component inside this, high-level architecture design, which will consist of the map tiling service, location and search services, and the most computational heavy, this routing and navigation service. And then we'll also go and explore this data model and storage. How does this look like? Once we have this clear understanding, right, then we'll go and see how this request flow, navigation flow will look like, right? When a request comes from the client, what happens behind the scene? Then we'll also cover the traffic update and route recalculation flow if needed. And at end, we'll just close with scalability and optimization. We talk about the in sorting, caching, and the load balancing. So that's our entire goal to cover in this particular video. Now let's move ahead and start maybe our discussion. So very first thing, what is our scope or no requirement? So we have to design a Google map. So very first thing is we need map rendering, display the map tiles, which I just explained, in above screen here. What basically means the map tile when we are saying anytime in the map tile, what do we mean by that? At a various zoom level. So zoom level, let's say the zoom level 0, when you say the very first time map loads, it might load the entire world map, right? A single tile kind of loading the entire map. When you zoom in further, we might load a country, right? When you again go ahead and zoom further, then we might go ahead and load certain cities, right? And then at the end of the day, we might be loading the street view. So that is kind of the what do we mean by the zoom levels. Then we also need to provide location and search services. I mean, converting the addresses, geocoding and reverse geocoding. Geocoding is basically converting all the addresses to coordinates, and reverse geocoding just vice versa of this. Then we also need to have the routing and navigation service. This is the minimum thing required, right? Calculate the optimal route between the 2 points and consider the real-time traffic update as well. So that estimated time arrival is mostly, accurate. If possible, we'll try to cover this POI nearby, businesses or landmark. How do we cover this? So that's overall the kind of the scope for us. Now let's go and try to see what would be the functional and non-functional requirement in this scenario. So from the scope, mostly the functional requirement is clear. But let's see this functional requirement. One of the requirement would be the displaying the map, or display the map tiles quickly, on all the zoom levels. Provide the option for the location search where the user can search for some coordinates, some landmark or anything. The routing, calculate the optimal path between point A to point B. Optimal basically could be the fast data. Then the real-time traffic. We have to provide some way, let's say the traffic injection API, so that we know what is basically, the traffic on between any path, right? At particular given time. So let's say on Monday morning, 8:30 a.m., traffic might be high, right? So we need to know how this has been happening. For this, maybe we'll see some concept of time series database, which we'll discuss later point of the time. Then another thing is the POI search, finding the nearest restaurant, gas stations. So this is overall the functional requirement. When we are discussing the non-functional requirements, it should be highly available. That means mostly it should be available 99.99 uptime. Downtime, the key metrics will be measuring into the minutes per year. Per year. It should be low latency. That means the map tile loading and source result, must be available instantaneous. Latency P95 will be expecting around P95 less than 100 milliseconds. Similarly, it should be scalable. It should handle billions of record for our use case. Accuracy routing, I mean path between two A and B, any nodes, right? It should be highly accurate based apart from that ETA calculation as well. Durability, our goal should be there should be zero data loss. So whatever the map tiles data or PI information we have, that should be stored in our database. So these are the both functional and non-functional requirement in our case. Now, when we know our requirement, maybe we need certain calculation, right? As we know, most of the uh, data which we need for the map tile loading and as well as calculating, the real-time traffic. So let's do some calculation how, the tiles loading, how much, space we need for this. And then based on this information, right, calculation, if you're able to infer something. So let's say one of the assumptions which we can make, how many daily active users we will have. Maybe we can have the billions of user, 10 to power 9 users, right? And what about the views per user? So we are just assuming a user will be opening map 10 time in a day. So 10 views per user per day. What about the tiles per view? So we are assuming, we will be loading 20 tiles will be loading, for each view. So every time we are opening our map, we are just assuming we'll have in around on an average around 20 tiles will be loaded. So 20 tiles per view. So now total map view per day, what will be the case? That will be this 10 to power 9 into 10 views per day, right? That will be 10 to power 10 views per day. And what about the total tile request? That will be 10 to power 10 views. And we had this 20 tile, per views, right? That would be 2 into 10 to power 11 requests per day. Now then what about the average request per second? That would be again simple to calculate. 2 into 10 to power 11 divided by 24 into 3,600 seconds. That should roughly come around 2.3 million RPS. Then we need to consider what could be the peak or request per second. Safely we can assume twice of our usual traffic, which can be around 6 million RPS. So now based on this data, now let's see the tile storage, how much time, how much storage we need maybe. So just assume that average tile storage is around 50 KB per tile. That would be the storage for each tile. And the zoom level, just assume we are supporting 20 zoom levels. What do we mean by that? That the very first time if map is loading on the zoom level 0, right? Or we are loading entire map. If you're zooming level from 1 to 4, maybe the country, 5 to 6, maybe city, and so on. We are just going, and when you're at the 20th zoom level, we might be showing, the street view to you. So we're just assuming we're supporting around 20 levels. So based on this, total storage of tiles should come around, this 70 PB. which is a really huge storage which we need. So based on this information, one thing which we can think definitely we need a CDN, because it's kind of massive read load requirement for us, request per second for these static tiles. So definitely for this static content, we need some certain global CDN as well. So based on this data, we can infer we definitely need somehow some global CDN for sure. Now, what about the real-time traffic? How are we going to calculate this? So for this, maybe what do we need? We need, there can be multiple smartphone user having, multiple smartphone, and maybe in each 3 or 4 second, we need to know what is their current location. So this data will be kind of ingested, into our system every 3 or 4 seconds from those millions of devices. That's why we will be able to know if there's some path exists A and B, how many active users are currently, on that particular path. So for this, what we can assume, let's say assume we have around 100 billion devices, 10 to power 8 devices, and report frequency, this can be customized, but just let's assume every 3 seconds, we are reporting it. So one report per 3 seconds, coming into our system. So total write per second, in this case, what will happen 10 to power 8 divided by 3 seconds, that will roughly come around 33 million write per second, which is again, extremely write load for us. So based on this, one thing which we can now, safely assume that this is really a write heavy operation where around 10 of millions of write per second is required, right? For this calculation of the dynamic data. So, which will definitely need some highly scalable in the distributed key value store to store this data, as well as to calculate based on the duration, right? Let's say from A to B at particular which time, what is the traffic load. We need some time series database, and to process this, we need some stream processing engine, could be a Flink or something. So this could be one of the, which we can infer, from this particular data, which we'll definitely discuss later point of time, like what would be the time series database, the stream processing and Flink and all, right? Now we have the calculation of the data. Now let's go and see the API. So for our Google Map API, one thing which we know the rendering of the map tile, right? So if we are at any particular location, let's say A. So what we need that coordinates x comma y, and to load how many tiles, we definitely need, the zoom level, at which particular zoom level we are there. So since we just assume we're around 20 zoom levels, so we need to know the zoom level as well. So for this map tile API, we need a get function with parameters g, x, and y. G is nothing but the zoom level, and x, y is the coordinates. Once we have this data, this API will retrieve the pre-render, map tile images from the CDN. We'll see how we are going to store these images. Will it be a image or like vector or raster process? Maybe we'll discuss again in later point of the time. Then for the routing, what do we need? We need the start and end location, start latitude, longitude, end latitude, longitude, or maybe driving mode. Uh, if this could be an option, not mandatory parameter, this can be calculated based on this particular data. So let's say if I'm on certain A's, right, and if we can see there is too much, of fluctuation, for the traveling, right, we can assume this could be a two-wheeler. If its path is kind of pretty straight, we can assume this could be a four-wheeler. Today, generally, Google Maps provide an option like whether we are driving using two-wheeler or four-wheeler. So that's why this could be an optional parameter, but that's not a mandatory. This could be calculated, based on this data for sure. So this will calculate the optimal route, including the real-time ETA, whatever the data we have from the all the devices being reported to us. So to calculate the real-time ETA, we definitely need the traffic API, which will be a post for us, where we need the device ID, current location, latitude, longitude, timestamp, and maybe speed as well. This will ingest, the real-time location data from the client devices to us, into our system. Then we need the search API for the geocode and reverse geocode. In case of geocode, it will be addressed into the string format, which will be converted to the latitude and longitude. In case of reverse geocode, we'll have the coordinates, which will be converted to the human readable format. Then the final API which we need for the POI, the nearby search, right? where we need the latitude, longitude, and the radius in the query, right? So if I want to find from here, right, from my current location, nearby pizza shop, right? So I definitely need my current location, the radius, maybe, the nearby locations, and what is the query. Query could be the nearest pizza location. Then it will kind of return me, the find save routes data with me. So with the API, I think mostly now we are good. Now let's go ahead and then see the high level architecture in this case. I hope I'm not going too fast, but yeah. So for high level architecture, let me open this. Yeah. So our high level architecture will mostly consist of three layers: client layer, application layer, and the data layer. In client layer, we'll have the mobile, we can have mobile app or web browser. What they'll be responsible for. Uh, So the client layer, they'll be mostly used for calculating the required map tiles based on the zoom label, whatever the zoom label which we have. Then it will also be responsible for assembling the received tile and rendering the map at the client side. This will also manage the local tile, route and caching the data. Apart from this, this will also send the real-time location ping to the traffic service. So we'll have the traffic service, where we need this all-time, the location data. In application layer, we'll have the load balancer API gateway, which will be kind of, receive all the inputs from the client location and direct data towards, the respective microservices. So let's go and see the load balancer and API gateway. Their responsibility should be mostly handling the SSL termination, rate limiting, authentication, and then routing the request to the appropriate downstream microservices. Could be the tile service, search service, routing, or anything else, right? So we have covered this maybe on the high level on the map. Then we'll have the map tile service. The goal should be, kind of providing the tiles to the client, right, based on the data. So this will calculate the tile coordinates from the request parameters and direct the client to the nearest CDN to fetch the, the static tile assets. So that's the end goal of this map tile service. This request is going to the CDN. CDN is actually the actual data storage will be the object storage, which we'll talk later. Then we'll have the search service. Search service will be basically, whatever the query we are passing from the search index, could be Elasticsearch or maybe the custom search. It will return with the responses to the user, right? So this will handle all the geospatial search queries and any POI search information. The queries will be to the search index and maybe the NoSQL DB as well. Then we have this routing service. Before calling the routing service, let's see the traffic service now. The traffic service would be basically, this will be helpful for calculating the real-time ETA, or what is the traffic between two any areas, right? What is the traffic? So that traffic calculation will be done by traffic service. So this will be a high throughput stream processing service that will ingest millions of requests per second location ping from client, and then this will calculate the average speed for each path, and this will also provide the dynamic age weight to the routing service. So what do we mean by the the age? So let's say if I'm point A to point B, if there is certain age, the weights could be the distance between these 2 points. Let's say the distance would be 2 miles, and then how much time this takes. This takes, let's say, 30 minutes, right? So this 30 minutes is mostly coming from this traffic service. So this is what the weights basically mean by this. So this weight will be dynamic calculated based on whatever the current traffic data which we have here. Now let's move the data layer. So in data layer, we have the CDN, which will be kind of a storage for all the any static content, right? So this will serve all the static content. In our case, could be the map tiles. Map tiles, we can use the raster or vector, which will see which one should be useful in our use case, right? At the later point of time. Then we'll have the object storage. This will be the origin storage for all the pre-render map tiles will be stored here, and any other static content, let's say the POI information or something, that will also be stored into this object storage. Then we'll have for the graph, right? We need some key value pair, right? So we can have some object storage, NoSQL DB, Cassandra, or Bigtable, right? So we definitely need this table to, our sharded root network graph, which is consist of graph basically consist of the node and edges, right? So I can have point A, point B, point C, D. I can have directed graph. So mostly routes, any path will be directed in our case. Why do we say the directed? If I'm going from A to B, the distance could be 1 kilometers, right? But the another way, the time calculation, it might take 20 minutes. But if I'm coming from the B to A, the distance can again be 1 meter, but this might take 30 to 40 minutes, right? So that's why whenever we are saying the edges between any 2 points, those will always be directed, which we can safely assume. Then we need the Redis cache. Why do we need the Redis cache? So let's say most frequently used routes, definitely we need to, store in our cache so that we don't have to, recalculate every time our optimal route from point A to point B, right? So for that, we definitely need some Redis cache. Then we need some search index, elastic search or custom. This will be a specialized inverted index, which will help full text or search queries to support any kind of search services, which is available here. So I think on high level we just saw how does our how diagram looks like. Now maybe we can just go and one by one explore deeper for our diagram, like how these things basically work behind the scene, maybe. So first and foremost, the map tile rendering services, right? So what it does basically behind the scene, if you see, so maybe I'll come to this diagram. So as we discussed, we'll have the 20 zoom labels, right? So map tile service basically, will have multiple zoom label. So let's say if I need some street view, right? So at the zoom level 0, maybe let me, yeah. At zoom level 0, we can draw entire one, right? Which will have one tile. If you're doing a zoom in again, so we might be rendering, some country. So we need, uh, we need multiple times for that zoom. So what it does, maybe 0 to 5 is nothing but maybe you can think of entire map. The zoom level 0 will be entire map with only one time. When you're going for, 1 to 5, this might go and load, the entire country. 6 to 10 maybe the cities, and similarly 20 would be kind of, your street view. So calculation wise, the same thing maybe, let's just go and see the calculations maybe for this. So for world, maybe we need one row and one column, which will be the one tile only. For continent, maybe, if I'm on a continent, let me, so if I'm going to draw a continent, maybe two rows, two columns should be the four, right? And so on. So for the 20th, like the street or building view, we need 4 to power, 20 tiles to draw that. So that's how this tile service will go and, render the tiles depending on, which particular zoom level we are there. So in our request information, we'll be having certain zoom levels. So how many tiles do we have to render and at particular which coordinate? Based on this information, we are going to, render the tile. The tile service will render based on this information only. So every time if we definitely need the coordinates x comma y and the zoom level. Based on this zoom level, how many tiles do we need? That can be calculated from here, which is basically stored into the S2. For example, you can see for the world zoom level, this would be one tile which can be drawn, right? For the city zoom level could be looking like this way, and the street level might look like this. Now what about the tiles? What is the type of the delivery of the tiles, right? At any time, let's say if I'm A to B, right, I can have it into the raster tile or the vector tiles. Raster is nothing but the images, PNG and PNG or JPEG, right? So they are kind of heavy to store, and one of the downside, which you can think of, let's say for the traffic, if my traffic is increasing and I want to have some color coding here. So let's say I want to do the red color coding if traffic is increasing, the yellow color coding if I have the better traffic, right? So that can't be done on the images if I'm going via the raster route. So these raster tiles are mostly used for the satellite imagery. For the real-time traffic data, where we need some dynamic color coding, this might not be helpful. In our case, that could be the vector tile approach could be helpful, where what it does, it stores all the points, lines, or polygon information in a compact binary format, and it send it to the client. Client is basically now responsible uh, based on this data. It renders the map locally, and if we need certain color coding combination, now this can be definitely applied to the client side layer. So that's how the map tiles will be basically loaded. Now let's go and see for the location in search. So we just cover the map tile services. Let's see the search services, how the search services basically behind the scene works. So for this, basically, we will need some NLP for parsing the query, right? Whatever the query is coming in our case, we need some natural language processing to parse the query. And some normalization process. Normalization process basically means, let's say the user is typing ST or street, N versus north, right? These could be normalized based on whatever the user is typing. Then the system, what it will do, it will query a massive inverted index, similar to, you can think of the Elasticsearch or the web search, where the address components basically are mapped to the S2 cell IDs based on those coordinates. In case of reverse geocoding, that would be the easier, because let's say if I'm at particular point A, if I know that coordinate x comma y, right? So I know which particular tile to load for that, right? So this would be easy to identify. System identify this cell it belongs to, based on the coordinate system. For POI search, basically we need some search index, the elastic or the custom, anything could be there, which will use, which will from the dedicated index, it will return me the responses from the S2 cell IDs. For auto completion, we'll have the try structure, which will help me, to provide the real-time suggestion whenever in the real time, the user is typing something from their keyboard. So now comes the most heavy computational, the traffic service or the routing service which we can say now. So let's explore this. Maybe for the routing, we'll be using some concept of the hierarchical graph model maybe now. So what do we mean by the hierarchical graph model? Let's maybe explore this. So let's say if this graph belongs to some city, right? We are in some city. I want to go from point A to point H, right? So I can have multiple nodes A, B, C, D, right? E, F, G, H, I, right? So if I want to go from A to B, I need to run some path finding algorithm digester, right? So I need to know how many exit points are there from here, right? And based on this, need to find the optimal path, right? So if you see in this case, maybe digester is out of the scope, but if you see, this could be one of the optimal path from A to B to C to H, right? But to calculate it for each node, right, whenever we are going, right, I need to know how many exit points are here, which is the optimal path among all of them. Then decide, find the best optimal path from here to here, then find all the exit points from here as well. Maybe then decide the next optimal path from this and maybe this one. If there is nothing, then come back again and see, right? So at each node and edges, right? Maybe at each node, we need to calculate mostly, all the exit point, how many exit points are there, and then which will be the optimal path, maybe optimal in our case, like in our source and destination, right? Which will be helpful for us. So this is really a computational heavy, and inside the city, this is really, easy to run this digital algorithm, because inside inside a city we might not have the hundreds of millions of nodes and edges. So this works pretty well when this is for when you're moving inside a city. What happens, let's say, when you are moving built between multiple countries, or let's say between states, right? State A and state B, right? Or some cities, city A, city B, right? So in this case, now let's say if I have multiple nodes and edges, right? And now I have to run register among all the points here and here, right? So this will be heavy computational, and this system will be pretty slow. So what could be the one of the optimal way to do this? Maybe let's say if I want to go from city A to B, I need to know how many exit points are there for this city and how many entry points are there for city B, right? Or state B. So in this scenario, maybe we are just going through example, one exit point and one entry point, right? But there can be two or three exit point and two and three entry points, right? So we need to know this exit point, how many exit points are there, and which will basically help us to go to city B, right? And then we'll try to find the optimal entry point for the city B from here, right? And now, then also we need to figure it out if there are some states highway or national highways, right? Because they would be far better compared to, any smaller roads, right? A smaller road might not be helpful for us. It will be always better to, find some national highways or state highways, which will basically connect to some other city for sure, right? Most of the times. So in this case, maybe you can think of this yellow line is nothing but some state highways, which is connecting two cities here. So now, most of the times now, in this case, it would be better if I'm going from A to M to follow this city's no state highway path. Now, if I have multiple highways, right? So if I'm at point A, now the this is, and this is, right? The calculation is of no use to me. So we can ignore these as now. So now my uh, this graph, how this will look like, this graph will be mostly looking like at point A, I have one exit point, which is B, right, to going towards the B. Similarly for the B, if I had one more exit point here, that is of no use to me. So I won't be, running my digital algorithm on those exit points. They might not be helpful for me. So now digital algorithm running on these edges, right, on this red one is of no use to us. Similarly, maybe if I'm coming inside this city inside this, right? That also might not be helpful. So for us, maybe these could be nodes which will be helpful for us where, we're going to run our Digistra. So now running the Digistra will be, it might not take, that much of time when we're going to run on these millions of nodes and edges, among the city. So that's what about the hierarchical graph whenever we are saying. So anytime we give the higher weightage to the any the state highways or national highways, and when we're going to move between two cities, we need to figure out which are the all the exit points, which could be helpful for us, and similarly for the city B, which could be the input points, where we have to go. So that was in short, maybe, what about this hierarchical graph model, maybe. So now let's go and see. Maybe I'll just go and read from here. So level highway and hierarchical intercity or intercountry routing, right? So level 0 will be the most detailed graph containing all the routes within the road network shards. So that is what about the level 0, when we're talking here. This was the level 0, which has, the kind of most detailed graph. But now let's say in the higher level, right, when we are moving between the cities, right, it will progressively, abstract the road networks by including only the more important roads, right? Example, the major highways or some roads, right? And shortcuts between the lower level partition. This form the highway hierarchy nodes, right? So that's what we call. For the intercity routes spanning multiple cities, the route algorithm primarily operates, on the higher level graph instead of this base layer graph, right? Running the algorithm on base layer graph is not useful for us because that will take more time for us, right? Yeah. For intercountry, for the global or intercontinental route, this search utilizes the highest level of, highway hierarchy for us, focusing on the major national or international highway. This will drastically, reduce the graph API calculation for us. So that's overall basically what do we mean when whenever we are saying, the hierarchical graph model for, calculating the routes. Okay, now maybe let's move forward if we're mostly good. This is one of the diagram created, maybe not too much accurate, but yeah, we can think of the similar thing, whatever we just talked, right? Let's see. So whenever the user requests some start or endpoint, it will go to the routing service. You can think of the same routing service, which we have here. It will check whether my data is in the Redis cache or not. If I have the data in Redis cache, just return to the user. If there is some cache miss, Then in between there will be some, graph processing service, which will go and determine the routes scope, or determine way how do we calculate that routes from here. So graph processing service, what it will do, it will see whether this request is for the intracity or maybe intercity, right? If intracity, then it will go for the road network sorts level 0, find the detailed traversal graph and return this optimal route, to the user. This will also in between, have the data from the traffic service to have the data for those SS as well, right? So that we can calculate the optimal route. If it's intracity, this will go instead of going for the level 0, it will go for the higher level of graph to calculate calculate of the optimal path between two points and return the data to the user. Now about the dynamic traffic calculation, right? Real time how we are calculating the uh, data. So for this, maybe this is real-time traffic service, how this is calculating the data. So for this, what it does, the system mostly, ingest millions of location pings per second. And this raw data is processed to calculate the current speed of, each road network. And this real-time traffic data, which we have collected from the user, is basically processed by some stream processing engine. You can think of the Apache Flink or Google Data Flow. This data dynamically updates, as weights into the road graph. So no matter how many S we have, mostly it will go and update the at the runtime, the edges as well. But there is cache we must have written somewhere. But however, the real-time data alone is not sufficient. Yeah. So let's say anytime to calculate the ETA, right? Only the real-time traffic data won't be sufficient for us. There might be chances, right? On some cases, right? There might be some work going on, right? So that road is blocked for some maintenance work or something, right? So we need to consider those data as well from some third-party APIs, which we definitely need. So the road might not be empty, not because it's clear, but because the road is closed, right? So we need to go know those data as well from some third-party API apart from the traffic data. The real-time telemetry, basically, it will the current speed from the active users which we are getting. We also need to calculate the historical trends. Let's say on Monday morning, 8:30 a.m., right? What is the speed look like? How is the traffic look like? So we need to store those data, for the long-term perspective as well. There could be some external factors like the weather condition, road construction, or some schedule events. This data maybe will be getting from some third-party API, to calculate the ETA in our case. Now the reroute calculation strategy, what will happen? Let's say anytime, right? Uh, if the user is going from point A to B, in between there are multiple points C, D, right? On this way, right? And then I have G and H. If I'm coming from this path, right? If let's say if I'm going from C to D, and then there is some path between C to H as well, right? If looks like if I'm going following ACDB, right? And what happens in the between? If the traffic looks like on this path is better compared to this flow, so that directly go and update now my traffic update to the client side. Maybe not. There should be, some threshold for defined for this. So for recalculation, right, there should be some computational threshold. Let's say if the average speed of the path exceed, let's say some 10%, right? If exceed that, then we are going to, update this to the current user. Otherwise, they can go and follow the previous path as well. This is really unnecessary that every time some recalculation happens, just return this data to the user. So we need to know, let's say if ETA from A to B was 30 minutes, right? So if it another point is, let's say, providing me around 20% of lesser time, right? Then we can go ahead and update that path to the user. But if that threshold, let's say the another path is just supporting, let's say 3% or 4%, improving the ETA, we might not need to update the real path for the user. Now the data model and storage, let's see how what all do we have. So we have some static map and tiles. This will be some large volume of data, right? Every time will be stored. So for this, the with the storage will be the object storage, the S3. And the indexing strategy, we are going to use the CDN. So all the static contents will be stored here into the objects, and indexing strategy, the CDN in our case. For the road network or graph, we need some key value pair. This will be again some highly constructed connected graph, some key value pair. This could be Cassandra or NoSQL big data table for us. And the indexing strategy, we are going to use hierarchical partitioning, which we just discuss right away. The hierarchical partitioning, maybe this one, right? So based on which label we are calling, which map we have to serve to the user. For POA data, this will be again high volume read and moderate write. For this, we can use the distributed key value pair storage. Indexing strategy will be the stoichiometry indexing. For the real-time traffic data, it's high write. The time series database we need. This could be the short-lived as well. So we need some stream processing engine Flink plus as well as the time series database for this. For search index, we need the inverted index indexing strategy. We can use either Elasticsearch or some custom search for our searching. We just discussed the time series database, right? Here. So what will be the use of this maybe, right? So this time series database we need. From the user, we know we have the high influx of the data, right? Which is critical for handling the dynamic nature of the traffic. So unlike traditional database, TSDB is optimized for the high velocity of ingestion. So let's say handling millions of location ping per second from the active devices, temporal query efficiency. So like efficiently query for querying what was the average speed on this road, maybe 5 minutes back, right? Or maybe the Monday morning, right? We will be knowing that as well. We definitely, from the time series database, we need to know the historical trend on certain edges as well, right? Which will be definitely useful, which it is helpful to, calculate in the better way. The data retention aggregation, maybe, so now we are getting millions of records per second, right? Every time in our system database, we need to downsample the old data as well. Let's say converting the per second pings to the 1 minute average and also store, the long-term historical data. So this is how maybe the data flow look like. The user ping the data to the traffic injection service, which will be go and process to the stream processing engine, maybe the Flink, and then store to the time series data base for the calculation, and the routing service will use to pass this data to the the traffic service to the to the routing service. Now let's go and see the detailed request flow, which is pretty clear, should be mostly clear, but let's go ahead and see, request flow as well. So now let's say if client is requesting a route from path A to path B, this will come to the load balancer, which will forward the request to the navigation service. Navigation service will check whether this path exists in our disk cache or not. If it exists, then it might return the route. If not, then this request will be passed to our graph processing service. So you can think of between this routing service and this data, there will be some graph processing service. And the goal of graph processing service is to find the optimal path based on whatever the calculation which we can make from this Cassandra DB as well as this time series database, and then return it to the user. So yeah, so in between there exists this graph processing service, which will find the road network shard where we have to make the query, and then from the time series database, the historical weights, right? It will apply on that, and then return the optimized path to the navigation service. And navigation services internally, it's going to return this data to the client side. In between, we also, if it's most used path, we'll be caching this data again, in our Redis cache for the storing purpose. Yeah, I think mostly things have been covered, whatever we are talking here. But let's say hierarchical routing, this service performs the hierarchical routing, the real-time traffic adjustment. This happens, based on if you're missing based on some configuration, right? So the traffic service will provide the latest is based on some real-time ingested data of those millions active devices. So what is this response delivery? The final route which we are returning to the user that will consist of the polylines turn by turn instruction that will be returned to the client and also stored into the Redis for the future use purpose. Then at the end, we need some, the WebSocket as well, because what is happening from the client side, at every 2 or 3 seconds, we are ingesting data into our system uh, to store into this time series database, right? So there, what we need, client sends the periodic location ping into our system via some WebSocket to this location service, which will internally, update our traffic model and triggers reroute calculation if traffic, condition changes significantly based on, certain configurations. Now let's talk about the scalability and optimization. So this entire world map is too large for a single machine to handle this. So the data is mostly partitioned geographically. So geographic sorting, let's say the S2 quadrant provides a natural way to sort the data. So all the data which fall within a specific level, S2 cells are stored on the same sorts. So this ensures that most of the local queries, goes to the single sort instead of, different sorts. For the caching is definitely needed. We need the CDN for static map time and in-memory Redis, for frequency accessing the data. On the client side as well, we'll be having some caching, like whatever the map which we have already, calculated based on the data, that will be storing caching on the onto the client side as well. We need some global load balancing so that direct the user to the nearest data center to minimize the network latency. For the internal load balancing, the distribute the traffic across the multiple microservice. We need some internal, the load balancer as well. So that's mostly pretty all about this Google Map design service, designing this Google Map.